All right, what you're seeing here is the Bear One. What you're seeing here is the Bear One ventilators have built-in humidifier unit, and then this is the heater controller unit by itself. Okay, it's just missing the bowl, which is the unit, the part that we put it underneath to fill in the water to create the moistures, and then the unit by itself have the controller on top of it. See if you can select it from 1 to, I believe it's the number 9. So actually it's really depend on how hot you want to set it, how hot the water you want it to be, right? And as the one that today we don't really use this kind because it's pretty hot. It doesn't have like a servo control, so this can actually create a very continuous heating. So it's not quite safe these days. So we have a newer unit that we use today in the hospital, right? So you can see that we have this unit mounted just right in front of the ventilator itself. Okay, just right in front of the ventilators. This is another kind of a humidifier that we use in the hospital. Normally, this one will be installed right in front of the ventilators, similar to the one that I previously showed to you. So let's see, we can show it to you. Okay, here, this is kind of the position that this humidifier is supposed to be placed in this place of the blue one. So we can remove the blue one and install this one. Okay, instead, so this is a newer one. It's showing that they have a different temperature control up in the front there. So it's very convenient that to really set what the temperature, what we want. Okay. All right, if you can see there's this new type of the humidifier, we can see that this is have the controller, right? So let's see, we can spec and focus. Let me see if I have focus. Let me try to. Okay, let me see this one. Okay. On the display itself, this is Fisher Pacard manufacturer. It have temperature control, and also the chamber control, which means is the this bowl here. The units have the bowl that actually this bowl we put the water in here, and then we place this bowl on top of this plate. This is like a heating plate right here. Okay, it's gonna get hot when we turn on. This is gonna get really hot. Then when we put water, we put distilled water in here. Then this is gonna go to connect to ventilators, and this side is gonna go to the patients. This is a breathing circuit that we connect to the patients at this port right here. And after the patient exhale, they're going to exhale out this one to go to the ventilators. on this, the white side of that breathing circuit, right? On the breathing circuit itself is have a connector or connect to temperature probe. So this temperature probe right here provide a servo control to monitor the temperature from the heating plate, actually from the bowl. Okay, we'll put the bowl on top of this unit. Then we have to connect the temperature control circuit. Okay, that's a temperature control circuit. And then we have this probe, which is temperature probe, to monitor the temperature at two different points. One is at the outlet. This outlet right here. You can see that the outlet, which is on top of this bowl right here. We are connecting that temperature probe right here, right? Oops, sorry. Nope. This one, and then this connector and the temperature probe should go to the side of the unit, right? You see that, right, to the side of the unit. Okay. And so right after we fill in with the water and we connect this to two connector here to the ventilator, we can turn on the unit, right? Yeah. So basically, the unit gonna run the self-test and look into it, say, okay, what the temperature, readings of the breathing circuit, if anything is not working right, the unit will give us alarms, right? So right now we don't have water in here, all right? We don't have anything hooked up to there, so it's giving us, some sort of alarms. And the thing here, the temperature probe keep reading. Right now is reading at the room temperature. It's showing about 19.8 degrees Celsius, which is the room temperature right now. That's what it's at the. I would have to say, this is at this. At this point, the temperature is at 20.1 right now. Okay, at this point. So, is the breathing circuit itself is giving us this ability. This is a special breathing circuit. They call the heated wire breathing circuit. What it does is keep moisture inside of this breathing circuit stay warm all the time until the gas is delivered to the patient. Okay. Yeah. So this one giving us the ability to check set the temperature, and also you can check the chamber control here, like a fine chamber control. But this one will not have ability to set that, the percentage of the humidity itself. So, the newer one have humidity control, which is a little bit different, which is I have to show you a little bit later. So, I'll show you that particular unit later. Okay. So right now it's keep alarming, but you see that we turn the heater on. You're gonna see that what's the difference now. The temperature keep rising, because what happened after we turn it on, we set that the temperature at 37 degrees. If you fill this heating plate here, we put the water in here, you can see the water start to get warm. And since we set that temperature, inside the chamber, supposed to be 37, that's what we're going to deliver moisture to the patient and air or mix gas to the patient with that temperature to keep that, the body of temperature of the patient warm. All right, so this is temperature is just, keep rising. So that means this unit is working, but it's just telling like, hey, there's no gas flow, there's something need to be checked because it's keep alarming. All right, so we have another kind of the humidifier unit. So this type of humidifier basically is have the built-in heating coil inside of this particular connectors. And what they do is this container here of contains water. We'll put basically they have a water in here, and it's normally will be distilled water. And what they do is they plug it into hospital outlet, and then hang it on the wall. So we have a flow meter right here to set what is the flow rate that we want to give air to the patients. And we have the connector here, and then there can be another outlet, and also we have another hose here that basically can provide that air, which is going to, this is a mask that's going to the face of the patients, and we can set the flow rate, and this will provide air and the moisture to the patients. Give to this is considered like a the air therapy type of device. It's very convenient that they use in a hospital this day when the patient have very, very dry throat, so they can get air of moist air breathing, so they can give very moist air, and to help them be able to put out secretions, or cough out the secretions. Is a lot easier when they have, dry secretions in the throat or in the nose. Okay, so this is another kind that normally we don't really service this in-house. We have to return this to manufacturer because this is not field serviceable type of unit. All right. Okay, the next thing I want to show you is oxygen blender. Okay, this is oxygen blenders. The purpose of oxygen blender is to mix oxygen and air and dilute the oxygen from 100% to different percentage that we want to give to the patients. All right. So the structure of the unit itself is it hard steel, this block, and the back of it have two inlet. One will be air inlet from the 50 psi, the working pressures for air, and then another connector here is for the oxygen inlet. Right. So these two are mixed, and after it's mixed, we can set up in the front here from 21%, 30%, 40%, 60, 80, 60, 70, 80, 90, 100. This is the percentage of the oxygen we want to give to the patient. After that, air and mixed with the oxygen and dilute oxygen, and we got the mixture. So the outlets over here will be different percentage, or the percent that we want to give it to the patient based on what we are setting over here. Biomed normally check the calibration on this once a year, and is required to send out for calibrations of every 2 years. But normally when we check the calibration, if it's still within spec, every 2 years we don't send it out unless it's very out of the spec much. We will send out for the calibrations. So this is one of the units that we always have to make sure that it's working properly. Underneath here they have, this is like alarms when the pressure is not equal, inlet from between air and oxygens. This will make a lot of noise, so you know that there's a losing of the air pressure or oxygen pressure, one or the other. Okay, it's very simple device, but it's very critical device. Okay, in neonatal ICU, every bedside have to have one of these hanging on the head wall, and they have like a flow meter attached to it. So we don't give the 100% oxygen to neonatals, okay, because that can cause the blindness to the baby. Okay, all right. That's oxygen blender.